Okay, let's go through some of these. So rounding to 1 decimal place. So I'm looking at 7, number after it's a 3, which means we round down. 2 decimal places, the 3, number after it's a 6, so we round up, so it becomes 4.74. Okay, 4 decimal places, 1, 2, 3, 4. Number after it's a 2, so we round down, so 4.7364. So the next one, 1 decimal place again. This is my first decimal place. It's not one significant figure. The number after that's a 7, so we round up, so it becomes 0.1. 2 decimal places is the 7. 4 means we round down, so it stays as 0.07. 4 decimal places. The 4th decimal place is the 3. The 1 after it means we round down, so it stays as 0.0743. Okay, 2 significant figures. So my second significant figure is the 3. Number after it's a 7, so we round up. So the 3 becomes a 4. 3 significant figures. My third significant figure is the 7. The number after it's a 2, so we round down. 1 significant figure, that's the 4 is in that first significant figure column, so I'm rounding to the nearest whole number, so 4. Okay, the next one, 2 significant figures. This time, that's my first significant figure, because it's the first digit of any value. That's my second. So the number after the 7 is the 8, so we round that up. Okay, 3 significant figures. So the third significant figure is that first 8. The number after that is also an 8, so that rounds up. So the 8 becomes a 9. 1 significant figure, so my first significant figure is the 4. Number after it's a 7, so it rounds up to a 5. Okay, let's look at the next one. So, okay, I want to do 1 decimal places first. So 4.4, 68.8, 0.1, 178.0. 2 decimal places. 4.39, 68.78, 0.08, 178.05. 3 decimal places. 4.388, 68.779, 0.082, 178.049. 1 significant figure, 4, 70, 0.08 and 200. 2 significant figures, 4.4, 69, 0.082, 180. And the last column, 3 significant figures, just fit it on, 4.39, 68.8, 0.0815, and 178. Okay, so let's move on to error intervals. So the length of a line is measured as 14 centimetres to the nearest centimetre. Let's look at the range of possible values. So if it's the nearest centimetre, 1 centimetre less is 13, 1 more is 15. So my lower bound will be 13.5, my upper bound 14.5. Okay, the number y is rounded to 2 significant figures. The result is 0.46. So the second significant figure is here in the hundredths column. So if I write that down, 0.46, hundredths column, so take 1 off this column and I'd have 0.45. Add 1 on, 0.47. So my lower bound would be 0.455, and I can add those zeros on to show where that comes from. My upper bound, 0.465. I get a mark for both of those. Your other mark is for having the inequality symbols the right way round. A number is rounded to 2 decimal places and the result is 3.76. Using inequalities, write down the error interval for n. So again, second decimal place is there. So 3.76, I've got 3.75, 3.77. I want those upper and lower bounds. Again, put that 0 on. So my lower bound, 3.755. Upper bound, 3.765. So 1 mark for the values and 1 mark for getting the inequality symbols correct. Okay, so here, error interval is given. Write down the error interval of y. So I've got 3.225. Y is greater than or equal to that, but it's less than 3.235. So 1 mark for the numbers, 1 mark for the symbols. So Z, 2 significant figures is 4,600. My second significant figure is in the hundreds column. So I'm going to go 100 less and 100 more. And then I'm looking for my upper and lower bounds. So 1 mark for the inequalities, 1 mark for my lower bound halfway between these, 4,550. Upper bound, 4,650. Mel is drawing a quadrilateral. The length is 6.3 to 1 decimal place. Let's have a look at the error interval. So my lower bound is going to be 6.25 because it's halfway between those, with my upper bound being 6.35. Complete the error interval for the perimeter. So if it's a square, a quadrilateral, square. If I know each side is 6.3 to 1 decimal place, in order to work out my lower bound, I'm going to do 6.25 times by 4, because each side's the same and I'd be adding them up. So I've got 25 when I did that calculation. Yep. Upper bound would be 6.35 times by 4. So 26.4. Is that right? 25.4, sorry. 25.4 is my upper bound. Okay. Right. So the mass of a girder is 11.7 to 1 decimal place. Complete the error interval. I've got 11.65 and 11.75 for that question. Let's have a look at the one after it. The length is given as 8 metres, corrects the nearest metre. So actually, if it's 8 to the nearest metre, the lengths it could be between are 7.5 and 8.5. The length of a piece of wood is given as 8.5, correct to 1 decimal place. So let's have a look at what the length of that could be. It could be anything between 8.45 and 8.55 metres. So this is the metal rod and this is the wood. Show that the metal rod could be longer than the piece of wood. Well, actually the rod could be, it couldn't be 8.5 because that could round up, but it could be 8.49 metres, and the wood could be 8.4 metres, and actually 8.4 is less than 8.49. So that's an example. You don't have to use that specific example, but something whereby the rod is longer than the piece of wood, and that bottom sentence is what gets you the final mark. So you get some of the marks for getting these and getting your intervals, but the final mark is for showing that example. Okay, now we haven't done truncation at the minute. Truncation is just if you had a value such as 7.98321, if you truncate that to 1 decimal place, you just stop at 1 decimal place and ignore everything after. So regardless of whether that's an 8 or not, that number truncated to 1 decimal place is 7.9. This number truncated to 2 decimal places is 8.63. That number to 2 decimal places is 8.71. Doesn't matter that number after it's an 8, we wouldn't round up. You always just ignore the numbers after it. So a distance was given as 5.73 to 2 decimal places. So the lowest number that could be is 5.730. But the highest number that could be is 5.739 recurring. So my error interval here, D has to be greater than or equal to 5.73, but less than 5.74. And it doesn't matter if you haven't got this because we haven't gone through it in much detail. So the last one, again, same thing, it's truncation. The error interval for X, it's greater than or equal to 7.4, but less than 7.5.